A constant problem for the military, exacerbated in times of crisis, is to move personnel and material around the world from where it's stored to where it's needed. Another problem is making sure that critical supplies are available or en route when they're needed. To aid in solving these complex problems, DARPA and the U.S. Army are creating the Logistics Anchor Desk to give logistics experts the ability to see the location and disposition of material around the world in a graphical, interactive manner. What we will show is that by adding voice input to the system's interface,
show me the roads,
the power of the logistics expert will be enhanced. Speech understanding is a key DARPA technology that is reaching the point of application. Speech allows users to concentrate on problems, not tools. It allows them to get answers quickly, and because speech is a natural way to communicate, less training of personnel is involved. The technology for speech recognition exists today in products such as the BBN HARC system. Speech understanding is the next step that will greatly increase the utility of applied systems, such as enhancing military readiness. As the following demonstration will show, it is becoming possible to produce, at reasonable cost, interfaces that integrate graphics and spoken language. The Logistics Anchor Desk is a system that allows logistics planners and analysts to address real-world problems during deployments and operations. In-transit visibility is key to effective planning. For the purposes of this video, we will be using the Logistics Anchor Desk in the way that it was used during the 1994 Louisiana Maneuvers, an annual war game which involves the simulated deployment of troops and forces in specific scenarios. This portion of the 1994 Louisiana Maneuvers simulated refighting parts of the Persian Gulf War. As a graphical simplification, transportation is shown on a direct line between ports of embarkation and debarkation. That means that tanks which exist on ships actually going around Africa, for example, are shown as if they were crossing it. The Logistics Anchor Desk has been asked to show the location of all M1A1 tanks and their transports. Each icon represents a specific location and displays the quantity of material stored at that location. At the start of the exercise, most of the material is located in the continental United States. In order to look at the projected location of the tanks and transports on day 150 of the exercise, the user can type into the date field above the map. But let's see how this is done using speech.
Go to day 150.
Most of the material has already arrived in the Middle East by day 150. Let's look at a day a little closer to the middle of the operation.
Go to day 50.
Now most of the material looks like it's in transit. Let's take a closer look at those tanks which are en route.
Go here.
Each of those spoken commands maps to simple form entries or menu choices. Speech has been added to the application with no knowledge of the Log Anchor Desk internals, other than what procedures to call to take the desired action. Now let's suppose the logistics expert wants to determine what material is en route and what material has arrived at its destination. If the cursor is placed on one of the icons, this information is displayed in the upper left corner of the screen. To find out the status of all material en route, we would have to visit each icon in turn and remember whether it is en route or has arrived. This is awkward. Some things are more natural to do with the mouse, some things with voice.
Hide the seaports.
By using a voice-enhanced approach, we are actually adding capability to the interface.
What items are en route?
Finding out which shipments have arrived is equally simple.
What items are in the theater?
By using speech, the user can ask for what he wants directly, without breaking his concentration to worry about the mechanics of the application. By day 50, 840 tanks and transports have arrived in the city of Jeddah in Saudi Arabia. If the logistics expert wanted to find out when the first tank arrived, it would require a fairly complicated sequence of mouse and screen operations. First, he would have to look at the manifest list for that location. Then he would request a graph of the material in the area by part. The tanks are represented by green diamonds, so we'll look at the green graph. The points on the graph represent the dates of arrival of the tanks. When the cursor is near the first point, the date of arrival of the first tank is shown in the upper left corner. He would then key in this date. Since the application can look up the date of arrival, it's more straightforward to ask to go to that date directly, and there are fewer chances for error.
When does the first tank arrive in Jeddah?
Sometimes it's easier for people to ask directly for what they want than to follow a series of menu choices.
Go to Jeddah.
The mapping component of the logistics anchor desk has a database of many geographical features in addition to political boundaries. In solving complex military transport problems, it's frequently useful to see these as well.
Show me the cities. Show me the roads.
Using the menus to turn on one of these features would require 7 mouse actions. What we've seen in this demonstration is that speech can change the way people communicate with their machines. They will be able to access information and get work done by thinking about the content, not the process.
When does the first tank arrive in Jeddah?
It means that personnel training costs can be reduced because speech is the most natural interface, and the collapsing of multiple steps into a single voice command means fewer things to learn.
What material is en route?
Because the system is built with off-the-shelf technology, speech recognition is easy to integrate into existing systems right now. And speech understanding is the next critical step to allowing natural voice interaction with complex systems. What we have shown is not a complete system. It is a concept demonstration which illustrates the potential in using voice-enhanced interfaces to improve military readiness. We've exercised only a few of the capabilities of the logistics anchor desk. Work must still be done to achieve a usable system containing a larger vocabulary and more advanced language understanding techniques. In particular, we need to make speech recognition more robust by making it perform better for a wide variety of accents and environmental conditions, by enhancing the dialogue aspects of interaction with the machine, including the human factors of spoken language interfaces, and by making it as easy to configure the understanding portion of the system as it is to configure speech recognition today. The result will be an interface that helps enhance the readiness of U.S. military forces and reduces the cost of logistical operations.